Good morning, everyone. I am Roberto Araya. I'm going to talk today about AI for education. First, I want to thank Professor Maitri for this invitation to talk to you about this very interesting issue. I'm going to concentrate on some aspects of AI and how can this help us improve education in our schools. So AI for education. Um, So how to improve teaching? How can AI can help us to improve teaching? I'm going to concentrate in speech and image processing, these two technologies. Um, one thing we want to be able to obtain is first how to get feedback from our teaching strategies. And second issue very important is privacy, because AI can get a lot of information from our teachers and our students. So how can we can maintain privacy? And third is has to be something that has to be scalable. It means that be able easy to implement in each of our schools that does not have a very impressive infrastructure. So first I'm going to talk about ideas of using speech processing. This is something that is have improved a lot in the recent years. So normally you have a speech like I'm talking right now, and that speech recognition will produce an automatic transcription into text. So what the teacher or the student says. Here I'm going to concentrate principally in the teachers easier than also having the students, but the idea is that you use this very powerful AI technique, machine learning. Then after we have text, in order to produce some kind of structure of the lesson from what the teachers said and also some of the students talk during the lesson. So speech, then translation to text, then the structure gets some features of the lesson that can help the teacher and the policymakers. There are two techniques here. One is talking about keywords, and the other is about vectors. I'm going to talk each one of them. Both techniques of language processing. Let's say we have a text like, let's say this classical Little Red Riding Hood story. You can do something like, okay, there are some important persons during the story. These are going to be the keywords. One is grandma, the mom, then Little Red Riding Hood, wolf, the woodcutter. And one kind of analysis you can do is how many times these words, these keywords, have been used during this in this text. So that's very popular now. They have clouds of words, and you can represent this. So somehow give you an information what's going on in this text. But you can do more. If you count how many times each one of these keywords happen in the same line, then you can see the connection between them because they're very close. And if you do this, it's very simple. But it's not only counting the keywords, but if they are almost in the same time spot, then you see this connection. And in this case, we produce something that the wolf is something behind the grandma. And there is some relation between the wolf and the little red. So you can capture the essence of the story, part of it, when doing this kind of algorithm, with just keywords. What we have done then, applying this idea, is taking the teacher use her own smartphone, and you collect the speech while teaching the class. And after that, from this speech, you get to transcription, then you get to this structure, as in the story I mentioned to you. I'll say here we have a lesson teacher A, a lesson teacher B, and we see some differences. And the notes here are the main keywords, could be the main concepts. Some of them are concepts with the content, some other are concepts related with the pedagogical strategy. And with both, then we get compared teachers. We did a study with some our um, partners in Finland, University of Jyväskylä, in several lessons that were teachers teaching exactly the same lesson, the same being planned. All of them had to teach a physics lesson. We had 25 teachers, they taught exactly the same, and we could see the difference in the structure of the lesson obtained automatically from the transcription of the lesson. We look at different metrics of this graph that is produced, and like diameter of the graphs, the density of the graphs, number of edges, number of nodes, and some centrality measure. Centrality means which are the keywords that somehow more influence the other keywords. For example, here you have an example. At the upper left, you start and say in the K, say it's does something, and the next moment it influences this two one at the B, where it's 1 and 1. Then in the third moment you have this spread to the node number 2, and then at the end number 3. So there is some nodes are more influential than others. It means some keywords, some concept could be content, or could be pedagogical content that are more have more influence than the others. So for each keyword, you can have this centrality measure. And what we did with them is that with analyze, and we found that there are certain keywords related with content and other with pedagogical ideas, strategies that are more influential than other keywords. And this is related with teacher learning. We have pre-tests and post-tests in each class, and we 25 different classes teaching exactly the same lesson, and we saw that certain structure, and the structures is measuring this centrality measure that are able to make the different classes different, and this has impact on the teacher in the student learning. Now we go to vectors. It's another technology. Let's say you have all the words in, let's say, 50,000 words, and the word here, house, sorry, it's Spanish, it's house, has a one. It's a one there. So it's just, this is that word. So the idea is that this is a big vector. You have a 50,000, a column with 50,000 rows, and just one there where is a house. And the idea is that instead of having each word separately and with big vector like this, it's the idea of Wittgenstein. Say the meaning of a word is usage in language. So if it's a word like mom, normally goes together with that, for example. So there's some relation with them. It's not just one word. So instead of using each word, you use the connection between the relation, with the correlation with other words. So, as another linguist says, you shall know a word by the company it keeps. So, what most important is the relation between words, not each word isolated. So, what we do, we use this idea, and we using the relation with other words. In order to capture this, we use the first idea is called the topic model. We put into them all the textbooks. In one case in science and math in Finland, and we found cluster of words who is related to whom. It's called topics. We did also the same in Chile. We took like 20 different textbooks and we tried to see the clusters. These are official textbooks of the words. The words are related if they are in the same page, and somehow we get like 60 different topics. And we see, for example, how these are two lessons, one electricity, 8th grade, electricity, the blue one and the yellow one, and somehow the topics they use each lesson. And with that, we could, in this case, we have maybe 20 lessons, and we could see the relation between them, and we did some cluster analysis and see that some lesson automatically, these algorithms are able to cluster them and see who is more related to whom. And here is another graph, is in the horizontal, is the time, like 90 minutes lesson, and how much is content related, is the blue line, how much is uh, administration related, the time, and other things is the green one. This is just one cluster of lesson. We have like 200 lessons, and we analyze of them, and we see clusters of way teachers use topics during these lessons. We can see clearly differences between the lessons in the teacher they teach. Another way, instead of using all the textbooks, is called using the relation between the words in the whole internet. So instead of using internet, we use the corpus of the whole internet. It's very big, very big. And the relation between house, for example, and maybe and on home is a big relation. But normally when one talks about house, also talks about home. So instead of having this big vector with just one in house and there is 0, we have this vector with all the relation with the other words. So we translate this into this. Each row at the right has this relation with other words. But we need to somehow to compress this because too big, 50,000 words, are different ways to compress this into smaller. And if we do this, it's called word to back, and this is translation to correlation, then to the compression. You see interesting thing, like for example, here we see queen is related to woman as king is related to man. So somehow the machine with these algorithms of, and after the compression, is able to see the relation between words and the knowledge of between words. This is very interesting. It's able to capture, for example, the relation between Paris and France geometrically is similar between London and England, and similar between Rome and Italy. So this is just the same in the same direction. There's a vector that represents these components. And for example, between dog and dogs, at the left, and cats, is the same relation. Somehow capture geometrically in certain space these similarities in semantics. So one way to capture this is to compress. This is what's called neural networks. We have house there, we would just one, and then we want to compress this as very small vector with all 300 rows, and somehow if we decompress, we get what we have initially. This is what techniques called neural networks are able to do, to compress the whole thing. And one of the recent algorithms that just last year was put to use by Google. It's called word to back. So, for example, you have beer here, and it's able to produce everything in numbers. So now you have this kind of algorithm that is able to produce these vectors, and they are very powerful. They are used in translation in between one language to another language. And now we were able to use this from what the students are saying and also teachers are saying. So we make the transcription. Once we have the transcription, we put every word into a vector, and even the paragraphs into vectors, just numbers. When we compress them using this relation between words obtained from the big corpus, not just the textbook, and then now we have everything in the mathematical world. And we make a mechanism called some attention that is able to see in a paragraph what are the main things that are being taught. And with that, we are being able to categorize, for example, different phases in the group of discussion between students, if they are just in the exploratory phase, if they are in the conclusion, if they are doing some experimental phase. So we have just published a study that shows that using this idea of transcription, vectorized compression, and then at some attention mechanism, we can have a machine learning that learns, that after some training, learns to discover or detect when the students are in this exploratory phase, they are like in the conclusion phase, in the discussion phase, they are doing the experimental phase. We can make the machine discover automatically, detect automatically these phases. At the same time, we're using in a smartphone an app to at every moment during the class. It's saying what is the teacher doing. For example, he's asking a question, he's doing is some guiding, the teacher is answering a question, it's discussion one-to-one to whole class, whatever. So we have hundreds of lessons that have been on real time. This is by another supervisor of the school that is at every moment saying what the teacher is doing. And we're applying this. For example, here is lecturing in the first row. The moment is lecturing. The horizontal time is the time from 0 to 1 hour. And I mean, when it's doing administration, this is the second row. The third row is asking an open-ended question. The fourth row is waiting. The fifth row is doing an experiment, asking multiple choice question, moving around groups, whatever. So you have through the time what's really going on, and where we have trained using this vectorization idea of the transcription is then train a system to be able to detect automatically these phases, what's going on. And using this, we're able to, for example, here are different lessons. Each that is a lesson where it's more related to content and science skills, content or math skills, and science skills or with math skills. So it's able to classify each lesson, the whole lesson, or in this case, it's just a lesson, just 1 hour lesson, and you have the trajectory that the teacher went through this, more related to content, more related to skills, and so you have, finally you can represent the whole session of 1 hour as a trajectory in this kind of spaces. BERT is one of the most powerful methods today. This was released by Google like 1 year ago, and is able to vectorize the discourse not only of words but also the whole sentence, and is able to predict the next sentence is going to be. Now it's used, very highly used and improved this method, all the automatic translation. And it was released in October 25, 2019. So it's less than a year ago that was released by Google and make a big change. And now it's a very powerful tool that we could use now to analyze lessons. I invite you to see, for example, this recently Springer publication. We have two publications there with our Finnish friends about automatic content analysis of computer-supported collaborative inquiry-based learning using deep neural networks and attention mechanism, and the other using topic analysis. Everything is trying to use AI to analyze real lessons. And the important thing is just using just this teacher's smartphone. And sometimes you need another to train this, another teacher, that the supervisor that is inputting what is going on. But then the machine learns with this machine learning algorithm to classify automatically. Here are some of the publications that you can see and read. And we started this in 2012, the first publication. We've been continue trying to do machine learning to analyze lessons. I mean, real live lessons from the talk of the teacher or sometimes the students. Okay, so this is about keywords and vectors, two ways of analyzing. Once you have the transcription, just concentrate on certain keywords, or you don't select keywords, but let the machine and convert everything to vectors, words or phrases, and then analyze them, and it's able to classify different phases of in a session. It's important that with this way we could get feedback for the teacher, feedback for the principal, also what's going on in his school, feedback for superintendents and for the ministry, what's really going on. For example, we're using now, let's say we have a new way of teaching something, like using technology. So it's a treatment. We see if there is differences between this treatment group, the way the teacher talk, and the structure of what's going on there compared to control groups where maybe the teacher talks different. Is there really a difference about after, for example, a program like a new training program or a new textbook or a new use of technology? The second, privacy. Since we have in the machine to translate everything to numbers and just vectors, you don't have the voice of each teacher and the voice of students. You have just vectors, so it's much easier to maintain privacy. It's completely anonymous. And then scalable. It's scalable because you just need not as particular equipment. You just need the smartphone, the teacher's smartphone. You don't need anything special more than that. Now let's go to speech to image processing. So what we can do with image processing. This is another very powerful technique that has been developed the recent years. For example, in face recognition, that's have a big impact in now face recognition kind of algorithm. So here we have what is this? It's dancing in a nightclub. These are people. What's going on? Let's see it again. Well, how about this now? Oh, it's the same. This is a classroom. We have the teacher, we have the students, and we take from all that information, we go to, we capture only the skeleton of each one of them. So interesting because we reduce all, we kill all the privacy problem with this because finally we get on not the video, but just this, as in the previous one, just this skeleton moving. But with this skeleton, can we detect non-verbal communication of the teacher and the students? For example, gesture during the lesson. So we have this skeleton with different part of the skeleton. Also, it's able to capture the hands also, so we can follow and track each one of them, each one of these points. And with that information, what we did is to train a system using this video with different gesture or not gesture, the basic thing, with different cameras. At the center was someone doing different gestures, like I'm doing now gesturing. And with that, we train a system and we get that images like that. It means, is there a gesture or not? Can you, in these 4 screenshots, which are gesturing? And here are other ones. Are there any difference between these and these ones? Well, these ones are machine detectors, the teacher is gesturing. This one says, I don't think it's gesturing. So it's able to learn this, and we just publish some results using automatic detection of gesturing. So, and this is done just very simple camera, again, using smartphone or using just a webcam from the notebook in the whole lesson. So after you record that, this will produce, instead of transcription here, we'll produce these skeletons, movies of this skeleton. With this skeleton, we'll produce, detect automatically the moments where the teacher gesture or doesn't gesture. And so we're in this phase. Later on, we want to more deep into into different kinds of gesture. Now just gesturing, and here you have some results and publications in automatic detection of gesturing and how this can help the teacher, principal. And again, with this, we can get some feedback if the teacher gestured enough or not, and later on we will want to produce feedback if the kind of gesture that the teacher does, yeah, if it's high, a lot of gesture, not too much, so and then we can relate with this student learning. Also, the privacy, that's very important, the privacy, because here, once you have everything translated into the skeleton, you don't have privacy problem anymore. So it's a way and reduce the whole information, and then you don't have this privacy issue anymore. And it's scalable, yes, because only you need your smartphone, or you need just a webcam, or just the camera that is in your notebook. That's all you need, and the machine will produce and able to synthesize and tell you a proportion of time you're gesturing. And in the future, we want to produce different kind of gesture, like deitic gesturing like this, or more metaphoric gestures like, this is a ball, something like a ball. And the other deitic is just pointing something. So this, what I think AI can do for education now, it's a really incredible opportunity to use to apply to education. Gives us new tools like a new telescope. Here I have my telescope, like a new telescope or a new microscope for analyzing lessons, and that as the telescope in astronomy and as the microscope in microscope as microscopes in biology. I think this could produce big enormous change in our ability to make observations, make experiments, and detect different changes. Thank you very much. Thank you for this. Yeah. Finally, are there any questions? I'm happy to hear and also find collaborators, work together with you in this enormous opportunity that AI brings to all of us. Thank you very much.